Hi everyone, welcome to my YouTube channel. In this video, I am going to explain you about wave nature of matter. So before going to start, if you are new to my channel, please subscribe my channel for upcoming videos. So this topic is very interesting, wave nature of matter. So as we can see here, the name wave nature of matter. So in classical mechanics, as we know, wave behave like wave, particle behave like particle. But in quantum mechanics, it is quite different. So that's why the theory has been explained here. So in the earlier days, if we take previous studies, we saw that light behaves both as wave and particle. So a particle is confined at a place. It is fixed. Particle is confined at a place by its position. On other hand, a wave is spread in space. So wave can move in a space, but particle is confined by its position or place. So as we have studied, light behaves both as wave and particle. So we say that nature of light depends upon our observation. If you are observing the different phenomena of optics like interference, diffraction or reflection, you will find that light is wave. But the phenomena like photoelectric effect that was explained by Albert Einstein, according to that phenomena, we call light behaves like particle. Okay, so as we can see in this figure, the wave nature and here particle is denoted by a dot, that is particle nature. So if it is traveling with speed of light, the value of c is given here 3 into 10 to the power 8 meter per second square approximately. So we have a question here whether light is wave or particle. Then we can have the answer here, that is it has both wave and particle nature, that is called dual nature or wave particle duality. It can behave like wave or it can behave like particle. So according to this hypothesis, it is an assumption. So according to this hypothesis, particle behaves as waves, which are called as matter waves. So the wavelength of the matter wave corresponding to a particle of momentum p is given by this formula. We call it as a de Broglie wavelength. So this was explained by the scientist de Broglie. So that's why the name, we call it as de Broglie wavelength. So this was explained by de Broglie in 1923. So h divided by p. H is what? Planck's constant. P is what? Momentum of the particle. So if we consider momentum, then that is related to mass. A photon having energy E has a momentum P. That means we have the relation between the momentum and energy of a photon. P is equal to E divided by C. C is what? Speed of light. So according to Planck constant, the energy of photon is given by E is equal to h nu, where V is frequency. So here we can substitute in this equation. P is equal to E divided by C. E is equal to h nu. Nu is what? Frequency, that is C by lambda. So we have this relation here. Then de Broglie realized that the above relation should hold for particle also. This, as we have written, this is for wave nature of matter. It can behave like particle. Then particle of mass m, velocity v, that is related to what? Momentum m into v. So it should have a wavelength given by lambda equal to h divided by p, that is equal to h divided by m into v. So this is what wave nature, and this is related to what? Particle nature. So that's why it matter can behave like wave, or wave can behave like particle. So in 1927, this was experimentally proved by Davison and Germer on nickel crystal. So crystalline materials means having the periodic arrangement of atoms. So according to this experiment, internal planar spacing of crystal is comparable with the wavelength of X-rays. So when beam falls on the crystals, wave reflected from different planes, which has a constant phase relation. So this was this wave nature or dual nature of particle, that is explained with the help of Davison Germer experiment. So after that, Schrodinger modified the concept of wave nature of matter. According to him, particle is not like a single plane wave, but it is like a group of waves. So that we call it as a wave packet. So it is just if it is group of wave, then it is just the superposition of waves of different wavelengths and frequencies. So this is all about the wave nature of matter. That was explained by de Broglie hypothesis. Particle can behave like wave, wave can behave like particle. That is dual nature of wave particle duality. And the equation here is lambda equal to h divided by p, or h divided by m into v. So some of the problems we can solve here related to de Broglie wavelength. So first let us solve the first question. What voltage must be applied to an electron microscope to produce electrons of wavelength 0.40 volt? So first, what is the de Broglie wavelength of an electron of mass m and charge E moving under a potential V? So lambda is equal to what? H divided by P. P is equal to what? Mass into velocity, momentum. If we write the relation in terms of kinetic energy P, then we can modify it and write H divided by root m into electron volt. So first we try to understand the question. They have given the electrons of wavelength having a voltage of 0.04 volt. Voltage they have given, then we have to modify the equation. Then if we substitute the value of voltage here and mass of electron, that is Planck divided by Planck's constant, we will have the above relation having the voltage of 936.3 volt. If we substitute value of voltage, mass of electron, charge of electron, and Planck constant. So next question, what is the de Broglie wavelength of electron moving with velocity v is equal to 3 divided by c? The de Broglie wavelength of a particle of mass moving with velocity v is what? H divided by m into v. H divided by m is what? Rest mass of electron. So m naught V. M rest mass is what M is equal to M naught by root 1 minus V square by C square. So if we observe in the question, then we can modify the equation and write it and substitute the value of velocity. If we substitute this, we will have the answer here 0.0323 angstrom, wavelength of an electron. Next question, you have 10 electron volt photon and 10 electron volt electron. Which one has shorter wavelength? Either electron or proton has the shorter wavelength. So first we will calculate wavelength of photon. Photon, lambda equal to h divided by p. P is what? E by c. Then substitute the value of given energy here, 10 electron volt for photon. You will have the wavelength of photon. Then go for 10 electron volt of electron. So de Broglie wavelength lambda equal to h divided by m naught into v. That is rest mass of electron. H divided by, you can just write in terms of energy, that is kinetic energy, 2 m naught E. So E value, if you substitute, you will have the wavelength of electron 3.88 angstrom. Here wavelength of photon 1240 angstrom. So the de Broglie wavelength lambda of particle is inversely proportional to square root of energy, and for photon it is inversely proportional to 1 divided by E. This shows that de Broglie wavelength of an electron is much smaller as compared to that for the same energy E. So electron wavelength is what? 3.88 angstrom and photon wavelength 1240 angstrom. Then electron wavelength is smaller than wavelength of photon. Energy of a particle at absolute temperature T is of the order of kT, that is Boltzmann constant into temperature. Calculate the wavelength of thermal neutrons at 27 degrees Celsius. And here they have given some required parameters: the mass of the neutron, Planck's constant, and Boltzmann constant. Then de Broglie wavelength of a neutron. First write down the formula here. Lambda is equal to h divided by root 2m into E. So is equal to h divided by root m. Here thermal energy we are discussing. So in terms energy, that is K into T is equal to, if we substitute value of given temperature, Boltzmann constant, mass of neutron and Planck constant, you will have the wavelength, that is 1.78 angstrom. So like that you can solve some of the problems related to de Broglie wavelength or wave nature of matter or dual nature or wave particle duality. So particle can behave like wave, wave can behave like particle. So this is the very fundamental of important concepts from quantum mechanics. So, and this is very quite interesting also. I hope this video is helpful for you. If it is helpful, please like, share and subscribe.